This is Geometry, Section 1.4, Angle Measures. So what is an angle? This is another fundamental concept that we're going to be dealing with all year long. So the formal definition of an angle is that it is formed by two rays with the same starting point. So down here we have an angle. So I've got two rays coming from the same point E that forms an angle. So we've got different pieces of an angle. The first is the vertex. This is basically the corner of the angle. So it's the starting point of both the rays. For this angle right here, that would be point E. So E is the vertex of that angle. We also have two sides of every angle. Those are the two rays that form the angle. So for this, it would be ray EH and ray EM. There are three possible ways to name this angle. So the notation that we use for an angle is this symbol right here. Looks like a slanted L. So we could call this simply angle E, because that's the vertex of this angle. We could also call this angle HEM, or we could call it angle MEH. We could either use one letter or three letters to name an angle, as long as that vertex is always in the middle. So for this angle, point E always has to be in the middle. So an important note about when to use one letter and when to use three letters: when a larger angle is split into two or more smaller angles, so as we see in this diagram right here, we can't name any of these angles with just one letter. Since there's multiple angles that are starting at point A right here, we cannot just call any one of these angles angle A. We have to use three letters to name it. So, an example, if we were to name the smallest angle, this angle right here on this diagram, we could call that angle BAN, or we could call it angle NAB. We need one letter from each side, and we need that vertex point to be in the middle. It doesn't matter which order we use, the B first or the N first, as long as we have that vertex point in the middle. If I were talking about this medium angle right here, I could call that angle TAN or angle NAT. Again, as long as I have point A in the middle. And if I'm talking about the whole angle, this whole thing, both of those angles put together, I could call that angle BAT or angle TAB. So, just like with line segments, when two angles have the same measure, and we measure angles in degrees, which we'll get to in a minute, they are called congruent angles. We learned the word congruent in the last section. So when angles are equal, when we're talking about the measure of them, we use an M to notate that. So if I were to say the measure of angle A right here is equal to the measure of angle B, I would be talking about the actual amount of degrees in that angle. Since both of these angles measure 113 degrees, I would say that their measures are equal. If I were talking about the angles themselves, I would say that angle A is congruent, again using that congruent symbol, congruent to angle B. So we've got different types of angles. The first is an acute angle. An acute angle is less than 90 degrees, and it would look something like this. A right angle is exactly 90 degrees. You've probably heard that term before. So that is equal to 90 degrees. An obtuse angle is greater than 90 degrees, and a straight angle is a full 180 degrees. It's a straight line, basically. So to estimate the measure of an angle, if you're asked to estimate the measure of an angle, it's easiest to compare it to either a 90-degree angle or a 180-degree angle. So if I look at this angle that I'm given right here and I compare it to about 90 degrees, which would look like that, that looks about maybe half, maybe a little bit more than half of 90 degrees. So half of 90 would be 45 degrees, so maybe that's about 45 degrees. If I look at this one, this right here would make a 90-degree angle, so this angle is going to be greater than that. So this is a small angle right here. That's maybe 20 degrees, so I could say this is 90 and 20 degrees, maybe 110 degrees right there. Same thing for this one. This would be 90. This angle looks a little bit bigger than that, so maybe that one's 30 degrees. So we'll call this a little bit bigger than this one, maybe 120. And this is going to be another acute angle, so this whole thing would be 90. This looks like more than half this time, so maybe we call that one 60 degrees. So the angle addition postulate, just like the segment addition postulate, is pretty intuitive. Again, a postulate is just something that's very obvious. If a point, or if point, Q, just like on this diagram, is inside angle, we could name this angle in different ways. I'm going to call it angle RED. So if point Q is inside angle RED, then the measure of angle REQ plus the measure of angle QED would be equal to the measure of angle RED. That's basically just saying if this is inside one big angle, then the two pieces equal the whole thing. Pretty intuitive. So using that, given that the measure of angle WOG is 42 degrees, the measure of angle LOG, the entire thing, is 130 degrees, find the measure of angle LOW. Well, if I know the whole thing is 130, and this piece, which is a part of the whole, is 42, I would just take the difference of that. So 130 minus 42 would give me 88 for angle LOW. 88 plus 42 should give me 130, my total. Same thing down here, just more angles. So if angle NAP is 60 degrees, angle TAD is 45 degrees, and angle RAT, this whole thing, is 80 degrees. We've got a couple things to find. The first is the measure of angle RAD. So again, we have this whole piece, RAT, is 80, and we've got that this piece, which is a part of that whole, is 45, then we need to find this missing piece. So if I take the difference of those, 80 minus 45 gives me 35 for this piece in here. So that's 35 degrees. Then I need to find RAN. Well, this one isn't as easy to figure out, but if we look at this right here, this is a straight line from here all the way to here. So all of these angles, these four pieces, 1, 2, 3, 4, those should add up to a straight angle, which is 180 degrees. So if I add up the ones that I already have, 45, 35, we know that those add up to 80 from over here. And if I add 80 and 60, I get 140. So to find this one missing piece in here, that piece would have to add up to 180 with the 140 degrees that I already have. So if I take the difference of those, 180 minus 140, that would leave me with 40 degrees for that piece right there, RAN, 40 degrees. Then we have all the missing pieces. It wants me to find measure of angle TAN. Well, just add up these three pieces, use the angle addition postulate. This whole thing would be equal to the sum of its parts. So 45 plus 35, we know that's 80, plus another 40 would give me 120 degrees. Next example, again, adding in some algebra. So measure of angle MAT is 5y plus 1. Measure of angle HAT is 4y plus 11. So, oops, we also have the whole. So measure of angle HAM is 75 degrees. So we've got the two pieces and the whole. Using the angle addition postulate, the two pieces have to add up to the whole thing. So 4y plus 11 plus 5y plus 1 would have to add up to my total of 75 degrees. Combine my like terms, 9y plus 12 has to equal 75 degrees. Subtract 12 from both sides. Then finally divide by 9, so y would equal 7. Now that we know what y is, to solve for these two angles, plug y back in. So for HAT, That's this right here. Plug in 7 for y. 28 plus 11 would give me 39 for that angle. MAT, again, plug in 7, so 5 times 7 plus 1 would give me 36 for angle MAT. Another concept involving angles is adjacent angles. So this is a little bit complicated. Adjacent angles are two angles that share a vertex and exactly one side. However, they do not overlap. So, what I mean by this, if I use this diagram to name an angle that's adjacent to angle ZEN, so that's this angle right here. So I know it has to share a vertex. All of these angles on this diagram actually share a vertex, which is E right here. So it has to share a vertex and it has to share one of the sides. I'm looking for another angle. Well, if I look at this side right here, there's nothing over here. There's no angle that I could name over this way. So I must be talking about sharing this side right here, EZ. So if I look for another angle that doesn't overlap with this angle and shares this side, I must be talking about this angle right here. Shares this side, and I can name that angle. So these two angles share this side in the middle, they don't overlap, and they both share point E as their vertex, so I'd be talking about angle ZEW. ZEW. Alright, and the next one, name all angles, so that means multiple answers, so name all angles that are adjacent to angle NED. So I'm going to erase what I have on here so we don't get confused. So angle NED is this angle right here. Again, I can't really use this side, NE, because there's no points or anything over here that I would be able to name an angle by. So all angles adjacent to that angle, I could be talking about anything that has a vertex of E and that has side ED or DE as a side of the angle. So I could be talking about this angle right here, DEZ. Or I could be talking about this angle right here, D, E, and then all the way over to W. That angle would also be adjacent to it, DEW. Next one, name all angles that are adjacent to ZED. That's this one in the middle. So now I can use both sides of that angle because both sides of that angle have other things on either side of it. So again, if I'm looking at that angle, ZED, I could be talking about an angle that's sharing this side right here. That would be angle NED. Or I could be talking about the other side, sharing this side right here. That would be angle ZEW. So, now explaining why the following pairs are not adjacent to each other. So we've got angle ZEN. Angle ZEN and angle WED. Well, both of those share the same vertex, but they don't have any sides in common, and in fact they overlap right here. So those would not be adjacent because they overlap. Angle NED, if I'm talking about this angle, and ZEW, this angle right here, those don't overlap, however, they do not have a shared side, which is a requirement for adjacent angles. And last one, NED, which is this angle in here, and ZEN, which would be this angle, all of this right here, which would mean I would have overlap in here. So that would not work because those angles overlap.